Hi everyone. Today we are going to discuss about VLANs. VLAN stands for Virtual Local Area Network. It's basically a virtual, smaller network that you create within the existing physical network. Now you must ask, why do you want to create a virtual network within your physical network? The reason is simple. Basically, it's a way to segment your network into multiple parts that are independent from each other. So you can assign some resources to one part of the network and then other resources to the other part of the network, and the network administrator can decide whether you have access or not to the resources on the other part of the network. And since it's a virtual segmentation and not a physical one, the resources don't have to be physically grouped together to be within the same VLAN. So let me give you an overview. So let's say you have 3 buildings, okay? So you have here building A, you have building B, and building C. So in each building, you have an employee here, and on the other building, another employee from the same department. Okay, let's say they are from the engineering department. All right, so you want them to have access to the same resources, so you group them together within the same VLAN. So you say, as a network administrator, this will be VLAN, for example, 100. This is just a name. It's totally random, okay? Then, on each building, you might have some servers that contain important data. So you want to restrict access to this data, so you group these servers within another VLAN. All right. So this can be, for example, VLAN 200. And as you can see, even if they are not physically or geographically within the same location, they can still be virtually within the same virtual network, VLAN. So, and then you might have your video surveillance system. So with the cameras here, and obviously you want to restrict access to these cameras, so you group them also within another VLAN. All right. So the benefits of having this type of segmentation in your network, well, first of all, the main benefit is security, because this way, as an administrator of the system, you can really decide which user, which part of the network has access to other parts of the network. So if you have an intruder that go to the engineering department and plugs a computer, well, that intruder would not have access to other resources, important resources of the organization. The second benefit, and that's a major one, it's bandwidth availability. So, for example, we all know that video surveillance generates a lot of traffic on the network, but we want this video to be always available. So we don't want, for example, if this person starts a file transfer to this other person's, that we don't want the bandwidth to be completely taken by the file transfer, and in that case you would start seeing pixelation in your video, or you would start seeing video degradation. We don't want this to happen. So with bandwidth management, with VLANs, you can decide that the bandwidth here would not affect the bandwidth available for the video surveillance system. Now this is the logical organization. Let me just show you quickly how this works at the network level. how this is achieved. And you will see this is actually very, very easy to set up. So the basic component of a network is a layer 2 switch. So you have switch number 1 here, and you have switch number 2 here. On each switch, let's say these are 24 port switches. So on each switch, you have a lot of ports, okay? And you have an uplink port that connect to the other switch. So here, same thing, you have an uplink port, and you have the 24 port to connect devices, computers. All right. So when you want to create your VLANs, the only thing you have to do is to say, okay, these ports 1, 2, 4, for example, they will belong to VLAN 100. And then you can connect the computers for, let's say, the marketing department to this VLAN. On the other switch, you also want to create the same VLAN, VLAN 100. So the people in the other building will also have access to the same resources. And the uplink here is what we call a tagged port. Basically, all the traffic coming in the switch will receive a tag saying, okay, this Ethernet frame belongs to VLAN 100 or VLAN 200, and the tag will be sent to the other switch. So the other switch, when it receives the traffic, it will say, okay, this belongs to VLAN 100, let's send it to the right place. And you can then configure the other port of the switches to different VLANs. Okay. VLAN 200, and on the other side, same thing, VLAN 200. All right. So this is how it is done physically on the switches, and this is how you can easily, just by allocating different ports to different VLANs, segment your network in a very effective way to, as we discussed, secure the resources and also to better manage the bandwidth available within a VLAN. A quick word on LAN switches requirements. To implement VLANs, it is necessary to use layer 2 switches. Not any switches, manageable switches, so you can go to the interface and assign different ports to different VLANs. Layer 2 is basically a switch that will operate at the Ethernet level, which is the MAC address level. Now, once you have your VLANs in place, they are independent from each other, remember. So if you want the ability to send information from one VLAN to the other VLAN, which is very often the case, you will need a layer 3 switch or a router, which is a layer 3 device as well. And once you get that layer 3 switch in place, you might have to implement other protocols, like in the case of multicast, if you want to route multicast traffic from one VLAN to the other VLAN, you must set up the PIM protocol, which has different mode, but the sparse dense mode is probably the mode that we recommend the most. So remember, if you want to implement VLANs, you need layer 2 manageable switches, and if you want communication between the VLANs, you need at least a layer 3 device, which is a layer 3 switch or a router. Now let's discuss how VLANs are implemented for video surveillance systems. I would say there are no best practices to deploy the VLANs because each system is unique. There are different scenarios. If the network is a shared resources between the organization, the employees, and the video surveillance, then in that case, it might be good to have VLANs for employees and VLANs for servers, cameras, viewing stations. So this way you can really manage the bandwidth, the security, and really separate the resources. You can have a very simple setup where the video surveillance system is all contained within one VLAN. So you can have servers, cameras, and viewing station all within a single VLAN. Or for larger networks, for larger systems, you can have a VLAN for cameras. So only people in that VLAN can access the cameras, like the integrator, for example, for maintenance. You can have a VLAN separate for the servers and another VLAN for the viewing station. So this way you really segment the network and you control which station has access to which server or which station has access to which camera. And this is probably the most secure way to implement your VLANs. When you have a really big system where multiple data centers are involved, then in that case, yes, you would definitely need some VLANs to say, okay, this data center has important resources, only people from this VLAN can access the VLAN of the data center. So that would be a scenario where VLANs are totally required. A quick word also on different issues that you can have when implementing VLANs. One that we discussed already is that you must configure a layer 3 device to have traffic going across the VLAN. For multicast traffic, it is necessary to have to define the PIM protocol with a sparse mode, for example. This requires configuring special features in the layer 3 device, like a rendezvous point. This is usually pretty easy to configure, but this is something to keep in mind. Also, when traffic is going across the VLAN, you want to make sure, especially with video traffic, that your core switch, your layer 3 device, is strong enough. I remember some cases where the core switch was dropping packets when redirecting video traffic from one VLAN to another because it was lacking resources. It was an older model with an older firmware that eventually needed an upgrade. So this is something to consider, especially when the system is planned to grow in time. You know that you must have the right equipment right from the start, or you must plan to upgrade the devices eventually. Something also to keep in mind when you have different VLANs, we discussed that a VLAN is a broadcast domain. So if you want to do camera discovery, when you install a new camera discovery most of the time works only with broadcast. Well, we have different options in Security Center, but most of the time it's done by broadcast. So you might be able to discover cameras only within a specific VLAN, but not across the VLANs. And some devices, older devices, sometimes they don't work well with VLANs, so it might be easier to assign, for example, the video devices in the same VLAN than the Genetec servers. And last but not least, you might have to adapt your network view in Security Center to take in consideration the limitations between the VLANs. So if multicast is working within one VLAN but not across the VLANs, then you might have to create different networks in the network view to reflect that reality. So that's it. That was the overview of the VLAN and how you can implement it for video surveillance systems. Thank you.